Hello again, this is Al, and this is, I guess, number 74 or so. 74. This would be an update, but actually there are quite a few little things that I want to mention in here, so enough to make this qualify as more than just an update. I did manage to get this to happen. Here's our first picture, anyway, which is just I'm just loading it from one of those files somewhere. There's an fopen and an fread. There's an fopen tcar version, and here's an fread. But between the fopen and the fread, there are quite a few things that are going on. First, in anticipation of there being more than one image, I declared this as an array, and I open that file. It's apparently in the current directory. That succeeds. File length, well, I can get to that. There are various ways to compute the file length, but I guess of interest is the way I chose to do it. As I said, there are many ways, but I decided to try out some of these functions I never used before and see how they work. Now, there's this thing, okay? ftel, which you've probably heard of before, right? Now that ftel doesn't take a constant pointer to file, right? It's only querying, but it requires a non-const pointer to file, or stream, I should say. And that makes me, and neither do these others, so that makes me a little bit wary about, are these things going to modify the file position? And also, if you look at this, according to my comment here, may not reflect the physical byte offset for streams opened in text mode because of character and line feed translation. Use ftel with fc for blah 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 to return file locations correctly. Now I know, and I kind of lost the code, but I know from past experience that if you seek 0 from current position, then that will seek the that will seek the file, that will sync the file pointer position in the file or whatever to the actual byte offset. So it looks like this line doesn't do anything, but in fact it syncs the whatever would be returned from ftel with the actual byte offset. Not that it matters in my case because it's not in text translation mode. This might end up in common, probably not. And I thought I'd try out the 64-bit versions just to see how those work. And the more interesting part, I guess, this should actually, I think I can say that. Because if we recall from DOS, and remember, everything's the same as it always was, there's also standard aux for the COM port, and another one, standard PRN, I think, are the 5 slots in the program segment prefix for a COM program that are always filled, and they're not seekable, and they don't have a size associated with them. So it makes no sense to ask for the length of any one of these standard files. We're going to find that again. What would that have been under? Those are the first three, standard error, and then some docs and PRN, I think, are listed in here. Somewhere. One of these old files had a little note mentioning ASCII art. Anyway, well, let's see if that's true. I'm sure it's got to be bigger than 5. Go. All right. Oh, it's already running. It's going to be 6, just as it was in doc. See, they have a thing that turns a stream pointer into a file number. Oh, it's 5. Oh, that's right. 0, 1, 2, 3, 4. Right? 1, 0. The standard in is 0. Standard out is 1. Error, COM port, printer port, and the next one, the first file that you ever open is going to have handle 5. Okay, so that's an interesting little historical thing, and from which there's a single function which returns the file length given a one of those what do they call them? File handle number, the entry from the job file table. All right. Now see, I'm seeking it back to whatever the current was, because I just don't trust these functions, because it's not taking a const thing, and it's probably doing what these things always do, which is seek to the end, seek to the 0, seek to the end, take the difference and get the size of the file, and then presumably return to the right spot, which I don't know if it works or not. Okay, but I don't think we're going to have to do that at all, for a very simple reason, which will come up in a minute. First, now I'm using globals for everything. This rect image, going back to the dialog here, it turns out I can make this any size I want, because the first thing I do is resize it to the size of the image. Although I resize it and I don't change it, so maybe that's a better spot. Let's see if it looks good. I should size it and center it or something. Sort of center it. little higher maybe. That's better. Yeah, so this is all using globals at the moment. What am I doing here? So now the way to determine the wrong function again. The way to determine the width and height and everything of a bitmap is very easy. A bitmap file consists of two headers, one a file header and then an info header, and then optionally a palette, okay, and then all the color values. There's no palette in these ones, and I'm asserting all these things, like the bit count is 24. I don't know what these planes are, but it should be 1. No compression. That the total size of the file is the file length I computed up there minus 2 headers, and everything else false. So if that's true, then I know that the rectangle for that entire image is just the width and the height, 0, 0 width, height. And now comes the device context stuff. Let me see how much time I've used. Too bad, not too bad. Okay, now remember I said that the control has its own device context. Whether or not that's required, I don't know. And now we're going to get to see how a device, one of the uses of a device context. Okay. And it's not really, it's not happening here. Well, first I get this device context thing from the begin paint, and that clip box I explained before. And then I'm using this thing called BitBlit, which copies memory from one device context to another device context. Okay, now this device context is just in memory. It's not associated with any physical device. But I have to create it in such a way so that it's compatible with this device context. And that's the magical part. And part that took me many hours to find. And where do I do that? Now first, there's this thing called create compatible DC. Now if you had a device context, then it's easy. You would just pass in the one you have. If you don't have a device context and you pass in no, then it's going to create a device context, 1 pixel by 1 pixel, black and white, 2 colors, that is compatible with the desktop device context, which is what I want. Now, in order to get the actual colors in there, so here I have what I have here is a memory device context. Okay. Now, what I need to create from my memory device context is one of these GDI objects. It says GDI. This is an HGDI object. Remember I was saying that in order to work with GDI, you need a device context and you need a GDI object like a pen or a brush or something, right? But one of those types of objects is this HBITMAP. I wonder what the help says. Ugh. No, it just says it's a handle, but trust me, it's a GDI object. Okay, it's not something you can use on your own. You can't do anything with it, but it can be used to draw on a device context. Now, this create DIB section takes a handle to a device context. Now that's one compatible with the screen. A constant bitmap data. Now that's this bitmap info that came from a file. Okay, and it turns out that that's just the header. If you look at you can use an extended version of this, but I use this one. Okay, that's a bitmap info header. There are extended ones for if you want to do more funny things like gamma, and I think there's even alpha. Yeah, you can provide alpha masks and so on. Don't need it. So I'm just using the regular thing I got out of the file. This next parameter is the usage. How are you going to use it? I'm just going to use color values, no palette. I hope you, I've been using the word palette a lot. I hope you know what a palette is. Palette is just a table of colors, usually 256 of them, so that you can map one byte to one specific color, and that means you don't need to store as many bytes. We don't care about that. Now this thing takes an address to a pointer to void. Okay, and that I've declared here, and two other parameters, which I'll explain in a minute. Null and zero means they're not used, so we can ignore them for now. This will allocate somewhere in system memory a buffer, which using this header information, which has all this stuff in it. Whoops, not that one. This is the one I'm using. Width, height, planes, bit count, size of the image, etc., etc. So it knows how big the thing should be and what format it should be in and everything. Allocates a buffer of just the right size for me to copy all of the color data from the file into there. And so if this Mem bitmap, HBITMAP thing is non-zero, and if I get a PV colors, now is there is the crucial step, the one that took me a while to find. You have to, like with any of these things, pens and brushes and so on, if I want to use this GDI object with this device context, both of them in memory, no devices involved, I have to select into the device context the object, the GDI object that I want to use. So once you've done that, okay, you can do that step here or later on. Now this is being used for this device context. Okay, so whatever goes into this memory is going into this memory device context. Device context that exists in memory. And now all I'm doing here is just reading a regular old file read into those colors, into this color array, the values from the file. And then I close the file. And then I run the dialog. Okay. I know this all seems complicated. In fact, it is complicated, which is why people invent even more complicated things to deal with it. But really, once you've sorted these 3 steps out, that's it. You never have to think about it again. Now, again, it's all global. Going back to our lab filter for messages. Going back to our WM Paint with the bitlet. If a WM Paint message comes along, first I have to get my own device context, call it by calling begin paint with the handle, the window handle. Now that's the handle to window of my custom control. And then bitlet is basically mem copy from one device context to another. Okay, and that's it. When the end paint occurs, when this line is called, that updates the device context of my window and causes it to display whatever happens to be in that device. When I used to do computer games, in fact, and most computer games work this way. Well, I can't show you full screen, but I can show you one of our games, the windowed mode version. If I can find it. I'm not trying to sell you anything because I don't get any money for it anyway. And one of my first jobs on this game was to make it work in windowed mode. This particular game can be played in windowed mode, as it's showing now, or in full screen mode, where the actual screen resolution actually changes, and it's not using device context or anything. You can write directly to video memory. So now what's going on here is what you do even with a regular even when it's in the direct screen mode, there's a display device context which gets displayed, right? But when you actually when you're drawing these images, you know, like if you're drawing, not that one, this thing moving around, right? That's not being drawn to the device context of the screen. Everything is always being drawn to a memory device context. And then every so often a function called flip occurs, where it switches between the memory device context and the screen device context, so everything that you've been drawing into that memory thing suddenly becomes visible, and then you see things, they appear to animate. You know, these things are looking like they're going around. Now, so that's similar to what's going on here. if you were going to draw the next horse or whatever, you don't draw it directly to your device context. You draw it to the memory. You draw everything you draw to the memory device context, and then when a paint message occurs, then you blit it to the. You would do a bit blit. In our case, there's no blit. There's a kind of a flip of one. You change the active device context or something. I forget. Now the weird thing, one of the things that you don't notice, and I can't really show it to you because I don't have it here. Do I have it? Probably not. One of our games has like a little car that moves around, and it's a bit long to explain. Let me see my time. Well, it's sort of interesting because you have to remember. Now, actually, this doesn't apply to the game I just showed you. But eventually, most games don't do this flipping thing as fast as they possibly can, because that makes it difficult to figure out like how to make things move at a consistent rate and so on. Instead, what they do is they have like a frame rate, so many frames per second, let's say 60 or 100 or something frames per second. So if you know how fast something's going, if you know how many frames are going to be drawn every second, you can figure out where the object should be at any given time, right? But that brings up a problem, because you see now if time is in chunks like that, and you're drawing something and you want it to make it move smoothly, right? Like it have the appearance of smooth motion, it's not going to do that. It's going to be sitting at one spot for a bit, and then suddenly it's at another spot, and then, unless it's moving very fast, you'll notice this kind of clicking, and it's really obvious if you just take, say, two pong balls and make them go, one with the fix for that problem and one without. One is going to be all jerky and the other is going to be nice and smooth. And the best way to explain it is with a picture. And I set this up actually. I turned off this setting here. I'm going to draw a line. Okay, now here is a line. This line is said to be anti-aliased, a non-anti-aliased. And you can see what that means. You can't draw a continuous line from here to here on a device that has where everything goes in steps, right? There's no middle. And so that's why people came up with this idea of anti-alias. If I turn it on and draw a similar line, see what it's done is, now if you zoom out, the difference becomes more apparent the further out you go. An anti-aliased line has the appearance of smoothness from far out. If I turn that off and draw a similar line, it's chunky, right? And the thicker the line, the worse it looks. That's all chunky. Turn on the anti-aliasing. and it's nice and smooth. Now you can do that same sort of thing. This is space. This is in space, but you can do the same sort of thing in time. That is, you sort of draw little bit like faded bits of the image of whatever the object is moving, right? So that you can draw something sort of halfway between two pixels. And you do that with the same sorts of techniques that does this anti-aliasing. It's a diversion, but it's kind of interesting, I thought. And I wanted to be in this program for another reason. And that has to do with those other parameters to this create DIB section. And the other parameters are, see, you can also pass it a file mapping offset object. I don't know if you know what a file mapping object is, but you can take a file. Let me take a file. I created I added a class here to common called map file just to do this. And let's call it NF for a mapped file. And it just takes a path in its constructor. And I will choose this file. Okay. So this is another way of accessing a file. And what it does is it creates, you open a file and you create one of these mappings, okay, then you close the file and everything. Once the mapping is created, that file becomes part of your memory space, okay? So now I can just say, because I've defined a cast constant, because these I've declared as read-only. PB equals MF, okay? And if I wanted to, I don't know why this works, but it does. Returns car PB. But first, let's step up to here. Now here, this PB thing here, that's just an address in memory. Now what happens to be at that address is all the data that was in that file. And it stops at some point. Now, for some reason I can print it out. I don't know how that works, but somehow it's finding a 0 at the end. I don't see a 0 at the end. Perhaps it has some checking. But it's just a memory space, right? Like if I said plus 100, right? It's gonna, whoops. It's gonna print out, see, it's starting from a different location. You know, to access a particular byte in that file, it's just PB of, you know, an offset. That gives you, you know, byte at oops. Now, see, that's a much easier way to work with a file than all this fopen, fclose, and everything. In fact, this thing even auto-closes the mapping at the end. You can also make these read-write. You could do this, right? If you wanted, if I made it read-write as well. One of the things you can do, although it's not being done here, is you can specify what address you want that file to be mapped to in your physical memory space. And that's one way that processes share memory, is they create a named, but this doesn't have a name, but I believe that, well, not this, but the mapping. The mapping can have a name. Yeah, see, name. Now, if it's named and opened with just the right attributes, then it becomes a shared resource, right? And if you and some other program decide on a name and an address, okay, any other program can map that same data into their address space at the same address. And that's one way you can do inter-process communication. You just, all you got to do is write something out there, and they can read it or write to it, and so on. So it's kind of interesting, and that happens to be what these two parameters are for. If you want, you could pass in a file map, and then it'll fill in the colors for you, and I don't have to do this part. Now, the other way to do this, there's two more ways, and I'll go over one. The way I would prefer to do this, and that's, check my time again. Okay, I can do this pretty quick because I'm used to this. This is how we used to do it. We got 10 pictures, actually 11 pictures. Now, one thing I can do, where are the pictures, is I can make one picture and put them all into a strip. Actually, you want to see the animation run, look here, and I'll just move my thing down. There's the animation go, right? So all I gotta do is play these pictures, right? I could put them into a strip, just like a regular film strip, or as I used to prefer to do it. Well, let's take one of them anyway. Get it in here. Get the dimensions. 220 by... See, 11's pretty close to 12. So what you could do is make a 4x3 array. So let's say it's 220 times 4. 880 and 149 times 3. And 9, 447. Oh, see, I already tested this, so that's why it's already set up there. Now, this thing has a grid feature, and I think it's Control-G. And I've already set the grid up to be the same size as these images. And so when I put them in here, if I can copy, edit, copy. Now what I don't have on is the snap. There. And then just take the rest of them. Okay, so the next one I want is 1. What did I just do? So that's 1. No. Not 1. How come I can't copy? Copy, Control C. Oh well. Oh, maybe Control Insert will work. Did. Okay, that's 2, 2. And 3. And 4. No, it's different. 5. 6. Even though you lose a little space, it's easier to look at the files this way. Is that the one I just did? Yeah. Whoops, that one goes here. Hand tool. How do I get the hand? Tools. Where are the tools? Oh, down here. There we go. Of course I can't pick it out and move it. Oh, that moved it. Okay, that was 9, I think. And that should have been 8. There. So now instead of having to open 10 files, I want bitmap, and oh, I'm in the right directory and everything. We'll call it course admin bitmap. Okay. If I didn't make a mistake, that's the animation all in one file. And now I can copy that whole thing into the into my memory handle to bitmap, which has been selected into that memory device context. And then in the bit blip, right, it's only a matter of choosing the correct offset. So I know it's 4 by 3, and if it's, suppose it's image number starting from 0 up to 10, if it's image number 6, right? So I do, to get the, hang on a sec. Alright, sorry, I just woke up. Yeah, so if it was image 6, you go, it's base, everything's base 4. So 6 divided by 4 gives remainder 2, so this is column 2. So it's column 2, and 6 divided by 4 is equal to 1, so it's row 1, column 2, and that's this one. So that's correct. So that gives you the logical coordinate of the image that you want, and then you just multiply by the width and height to get the actual screen coordinate. So to get the screen coordinate, it's image number for the x percent 4, right, and for the y divided by 4, and then multiplied by width, and then this one multiplied by height. The height of an individual frame. So that gives you the coordinates within the memory DC. Oh, sorry, this would still be 0, 0. It's these two numbers that would be replaced with that. One is source and one is desc, but I want it to go to 0, 0. I want the width and height to be what, well, that's what these are. Assuming I figured this out, another global. Okay, and that, now that's just a function of n image. This is draw n. Over this. Right? And then you would increment the image. This presumably would be a member of some struct. This whole thing would become some struct, like the dialog thing. And when a paint occurs, then you draw the correct image. And what we could use is a timer to trigger a paint message every so many milliseconds and draw the next image, and then we'll get our animation. Now, I used too much time, but I've explained a lot of things, and I hope it wasn't too much. Okay, see you next time.